on temperature conversions. So our goal here is to be able to convert from one temperature unit to another temperature unit. So it's just another kind of unit conversion that we have to concern ourselves with. All right, so in order to derive the equations that we want to use to make these conversions, what I want to do is compare three different temperature scales. So when we measure temperature, we can do it in the English system with degrees Fahrenheit, or if we're in the metric system, we can use either degrees Celsius or kelvins. Now, in order to do this, I want to compare these three different temperature scales. So we're going to pick 2 points on each scale to act as reference points. So those reference points are going to be where water freezes on that particular scale, and also where water boils on that particular scale. So I've already filled those numbers in for us so we can take a look at them and compare them. So if we're in the Fahrenheit system, we know that water is going to freeze at 32 degrees Fahrenheit. We also may remember that water will boil at 212 degrees Fahrenheit. Now, if we move over to the Celsius scale, most of us probably know that water freezes at 0 degrees Celsius and water will boil at 100 degrees Celsius. A scale that may be a little less familiar to us is the Kelvin scale. And what we will know is that water will freeze at 273 Kelvin and it will boil at 373 Kelvin. So there are 2 reference points across all 3 scales. So now what we want to do is we want to make some comparisons across the scales. So one thing I want to do is I want to see how many degrees it takes, for example, on each scale to get from water freezing to water boiling. So if I want to see this gap in degrees, all I need to do is take the difference between 212 degrees Fahrenheit and 32 degrees Fahrenheit. If I do that, you're going to notice that the difference will be 180 degrees Fahrenheit. I can do the same thing with the Celsius scale. If water freezes at 0 degrees Celsius and boils at 100 degrees Celsius, I can see the difference between those 2 points will be 100 degrees Celsius. And then finally, on the Kelvin scale, I can take the difference between 373 Kelvin and 273 Kelvin, and we see that difference also will be 100. Now notice I don't put the degree in front of the Kelvin. All right, so when we do this, we can start to see the differences between the scales. So we notice, for example, firstly, that since we get 100 degree units between each of these different reference points, we can say that the magnitude of a Celsius degree is going to be the same as a Kelvin unit. All right? In other words, if there were such a thing as a degree Kelvin, we could say that the magnitude of the degree Celsius would be equal to the magnitude of the degree Kelvin. All right, so what that tells me then is that I don't have to account for any difference in terms of the size or magnitude of the degree unit itself. The only thing I have to worry about if I'm going to be converting between Celsius and Kelvin is going to be the 0 point on the scale. All right? So what we notice is on the Celsius scale, the 0 point is going to be defined by the freezing point of water. Whereas the 0 point on the Kelvin scale is way below that. We actually know that to be absolute 0. And that's something we'll talk about next semester. All right, so going between Celsius and Kelvin is pretty simple because all I have to do is account for the difference in the 0 point. So let's say that I have a temperature in degrees Celsius and I want to get to a temperature in Kelvin. So let's see how we would do that. So what I would say is that the temperature in terms of degrees Celsius would be equal to the temperature in Kelvin. All right? And then to get the 0 points worked out, I would have to subtract 273. All right? So all I'm doing there is I'm reconciling the difference in the 0 points. Now, if I want to go from Kelvin to degrees Celsius, now all I need to do is just algebraically rearrange that top equation. So now what I'm going to do is I'm going to solve for T in kelvins, all right? And now I'm going to set that equal to temperature in degrees Celsius, and now I have to add 273 to that. All right, so these would be the 2 equations I would use to go between Celsius and kelvins. So in this case, if I'm given kelvins, and to get to Celsius, I would subtract the 273. if I start out with the temperature in terms of degrees Celsius and I want to get to Kelvin, I would have to add my 273 in that case. So those are the two simple cases. Now, what if I want to go back and forth between degrees Celsius and degrees Fahrenheit? Now I have two things that I have to account for. I have to account for the fact that there's a difference in 0 point between the two, but I also have to account for the fact that a Fahrenheit degree is not the same magnitude as a Celsius degree. Okay, we can see here that since it takes 180 Fahrenheit degrees to cover the same span that it takes 100 Celsius degrees across the same window, that tells me that a Fahrenheit degree is a little bit more than half the size of a Celsius degree. So I have to account for the fact that there's a difference in the magnitude of the degree unit itself, as well as the difference in the 0 point. So if I want to go between degrees Celsius and degrees Fahrenheit, how would I do it? So in this particular case, let's go to degrees Fahrenheit. So I want my temperature in degrees Fahrenheit, and I need to do that in terms of the Celsius degree. All right, so what I'm going to do is I'm going to now take the temperature in Celsius, all right, but now I have to account for the difference in the magnitude of the degrees. So essentially I'm going to put a little conversion factor in here. So what I can do is take the ratio here, where I want to know what I've got here in degrees Celsius, so that's going to cancel to give me degrees Fahrenheit in the top. All right, so this is where I'm going to use my ratio here. Notice that these are equivalent actual magnitudes. And I'm going to cover the distance between water freezing and water actually boiling. So in this case, I can generate a conversion factor based on that. So notice that for every 100 degrees Celsius, I'm also covering that same range in 180 degrees Fahrenheit. All right, so notice what happens. Celsius will cancel the Celsius units wise, giving me degrees Fahrenheit. Now the other thing that I have to do is account for the difference in the 0 point. Now notice if I'm at 0 here and 32 here, now in terms of Fahrenheit degrees, I've got to add 32 to that number. All right, so I've accounted for both of those things there. Now in many cases, you're going to see that ratio actually represented as a reduced ratio of 9/5. Okay, so another way you'll often see this written, as in most textbooks, is you're going to see that the temperature in degrees Celsius is equal to the temperature in the temperature in degrees Fahrenheit is your temperature in degrees Celsius times the ratio of 9/5, and then we add to that the 32. So that's typically how we would see that written. Now if I want to go in the opposite direction, so I want to end up with temperature in degrees Celsius, all I have to do is algebra on this, okay? So let's think about what I have to do. I have to take my temperature now in degrees Celsius. I'm going to solve for that over here, all right? So that means I have to take the 32 to the other side. So that means I'm going to have temperature in degrees Fahrenheit, and I'm going to subtract from that the 32, but now what I have to do is account for, again, the ratio of 9/5. Now since I'm going to divide both sides by 9/5, that's the same as multiplying the right-hand side by 5/9. So now we're going to end up with an equation that gives us something like this. All right? So those are the equations that I would use to be able to convert from one unit to another. And I think I actually wrote that backwards. Let's just fix that up at the top. This should be Kelvins going to Celsius. And this should be degrees Celsius going to Kelvins. Okay? I just wrote that backwards. So those are the equations that we're going to use. And the nice thing about this is pretty much just plug and chug. What I've got here is an equation. So for example, if I wanted to get to a temperature in Kelvin, and let's say I wanted to know the temperature at which water freezes in Kelvin from Celsius, I would just plug my Celsius value in here. I know that water freezes at 0 degrees Celsius. 0 plus 273 gives me the freezing point of water on the Kelvin scale, which is 273. And that's exactly what we see right here. So you can see it's just a matter of plugging one temperature unit into the equation and then solving for the other temperature unit. All right, we'll practice with this a little bit next time in class.